Hello everyone. Morning. Quick checking audio and video. Morning. Is it good? All right. Okay. Good morning, Ken. Good morning, Rachel. Amanda is here. Dylan, Justin. All right. Lexi, Tristan. Okay. Okay, class. So today we are going to study, to go over the last unit that it is going to be covered in test number 1. We have our first test in 9 days. It's very important that you should have taken the practice test on Alex, so that way you know if your device is ready for the proctoring system in Alex. If you haven't taken that, you need to do so. I'm going to be checking the recordings this week, and if there's something that you need to improve, you will receive an email from me informing you what you need to improve for the day of the test. Okay, there is a procedure that you need to follow. There is a contract that you should have submitted by Friday, telling me that you understand everything on all aspects of the text, how we are going to proctor your assessments. All right. If you haven't done that, and you have any technical issue during the test because you don't know how to proceed, or you don't know how to do a certain task, it could affect your grade. All right. We have 9 days to prepare for the test. If you have questions, you know how to reach out to me. If not, you make sure that your device is ready. Even though maybe your device is ready this past Friday, things can change in 9 days, right? So if you have any difficulty or any technical issue during this week, let me know to make sure how to make the proper arrangement for your test. All right. If your device didn't work well with the Alex proctoring system, then we are going to do a Zoom meeting that day on Wednesday, the day of the test. We are going to do a Zoom meeting where I am going to proctor over your test, and we are going to follow the same procedures. You're going to present to me an ID, a valid ID with photo and name and last name, and you are going to do the environment check, and then you are going to proceed to take the test. Okay. A few of you have reached out to me telling me that you are working on a room, so I got your name. So when the day of the test is near, then you will receive separate instructions. All right. But if you haven't done anything of that, you need to inform me with days before the test so I can prepare for, or I can send you the information ahead. Any question on that? All right. So like I said, today we are going to see the last unit that it is included on test number 1, and this unit is unit number 4, where we talk about quadratic functions. You will see that in my opinion, I'm going to talk about just in a moment of what you are seeing right now on the screen. But in a moment, in test number 2, we are going to go more deeply and more abstract in the aspect of functions. So we are going to talk more deeply about functions. In this unit, we cover more general aspects of functions. The most important is knowing how to transform those functions, and basically we are just working with the library function and the quadratic function. The quadratic function is an important one. I believe it might be the most important function that we're going to study in our class, because all the application that a quadratic function has in the real life, right? An example, the force that maintain us attached to the surface of the earth, gravity, can be described, or the behavior of a body under the influence of gravity can be described with a quadratic equation. And that is the reason why I'm presenting to you this silly concept of a square guy and an aspect of a 2D platformer game. So what I'm doing with this, I want to show a few things. The first thing is that I want to show you how we use functions. We know that functions contain two main aspects, if you will, the input and the output. My program that governs over this video game concept has an equation that determines the gravity that the player is going to feel in their world. The player here is this square guy here. And right now the game is in pause. I'm going to start the game when I click on this red button. The thing is that in this red button you are seeing g equals negative 9.8. Anyone knows, or do that number resemble to something from physics? Right? That number is, or g, which is a variable, and now I'm changing its value, is going to be the acceleration that this player is going to feel going downward, gravity, right? So g is going to be the input, and the output here, we are not going to see like an exact value, but what we are going to see is how this player reacts. So the output of the function determines how this player floats or jump or move in this world, right? Also, you can see that I have put in top of his head like the coordinates of its position, right? So that way we are seeing that the coordinate plane is still something important here in our in this video game concept, right? So so I enter g equals -1, and you see the effect of that player like floating in the air, right? But what happens if now we use -9.8? So its behavior changes, right? And that is the output. So the input is the value of g, and the output, so the behind all of this, in the core of this video game concept, there is an equation, a quadratic equation that determines the player behavior when in terms of the gravity, right? And that is the output. So that is one thing that I wanted to show you here. The other thing is that what about transformation? How am I using transformation here? So you are seeing this guy jumping up and down. What type of transformation is that? Think of this guy like a point in the coordinate plane, and this guy is going up and going down. Do you recall any type of transformation that we studied from unit number 2? Is what type of transformation has been used here in order to move this player up and down? How is this player changing? What about its position? Right? When you see this, we are seeing a vertical transformation. Going up, shift up. Yeah, Rachel, that's correct. So I use in transformation. What I'm doing is, whenever whenever I click on space bar here, which is the jump command, its y value position change, like I'm adding to its y value position. And then gravity, or the equation that determines gravity here, move this player down. There is more because this is a 2D platform game, so there is an X, this is a Y and X values, right? And I can change those based on the equation that I have or the functions that are in the program of this video game concept. Those functions are quadratic functions. Why quadratic function? When you're taking physics, if you haven't taken physics yet. So yeah, I'm going to kill this guy, and let's put this gravity this way, and you see now its behavior changes. So in physics, there is one topic in physics that it is called kinematic movement, I believe. The kinematic formula is a quadratic function, and that quadratic function describes the movement of an object or a point in the coordinate plane, right? And that is what we do, and that's what I did in this video in concept. I just use a quadratic equation to determine how this player move. All right. So I have shown you an aspect of real life outside of the academic where we use what we're learning here. Okay. This is not the only application that a quadratic function has in the real world. There's many and plenty of applications of math. Okay. In our journey, we are going to discover where we are going to apply what we have learned, right? And today, that's what we are going to do. We are going to learn about quadratic equations, and we are going to solve a few examples, practice our own a few examples, so we can start like connecting the dot and linking math with real life, right? In the workshop today that I do today, on number 15, I want you to know, or I want you to go to item number 15, and then these two items here under 15, under the item or the exercise or blank number 15 are very important. You need to know these by memory, right? Also, 16 and 17 are also important. We are going to get back to these properties, right? Because if you do not know these three items by memory, it's going to be very difficult for you to solve the exercises, and you will see why. Right. All right, so what I'm going to do is let's move to an example. All right. So we are going to work this example just in a moment. Okay. Let me set up this here. Sorry. All right. So the first exercise that we have here is one where we have two quadratic functions. Remember that in functions, we can get a function based on its function rule or equation or its graph. So we have function 1 and function 2. Both of them are quadratic functions. Now, what we need to do is to identify the vertex of both. all right? And then determine which of these two functions contain a larger maximum value. Right. So we know first from library of functions what we know. We know that the parent function or the parent square function is what we have here. Y equals x raised to the power of 2. Its graph, it is a parabola, something like this. All right. And now we are going to build up upon this information that we have. We know that this point here is going to call the vertex. And in a quadratic equation, the vertex is going to be the minimum value whenever the parabola opens up, or the maximum value whenever the parabola opens down. Okay. To be more specific, I should put the two options here. So here, the vertex is representing the minimum value, but if we have this transformation, that means if it is a vertical reflection. So now we have this vertex here. This is the vertex, and now this is going to be a maximum value. Okay. All right. So based on that, let's construct the standard form for of the quadratic equation. So the standard form is no other than an equation that represents in general what a quadratic function is. And you are going to see that it will contain x squared, right? So this is going to pointing out to the library of functions, so it is a square function, right? But now we are going to have a few things here. And let me put this here. There are a few things that are going to be different here. So A, B, and C. Let's use green for C. All right. So now, instead of seeing just y equals x squared, we are seeing this equation where we have three terms, all right? Every mathematical writing that it is separated, or any mathematical expression that it is between or it is next to a addition or subtraction operation, it is considered a term. So here we have the first term. Okay, then we have a second term, and lastly we have a third. I think third is RD. I don't know. Third term. All right. So we have three terms. So this is a how you call it? Trinomial. Trinomial, I believe, is the right word in English, or trinomial. So the thing is that here now we have three terms that represent a square function, where A, B, and C are coefficients. All right. So where A, B, and C are the coefficients. Okay. So the coefficients are constant value that are in front of the variable, or are going to be multiplied by the variable of that term, right? So A times x squared, B times x, C, it is going to be the constant term. It is the constant coefficient because it is in the constant term. This third term does not have a variable. So hence the third term is a constant term, right? So we call A the leading coefficient. Okay, A is going to be the leading coefficient because it is in the leading term. So the leading term is the one that contains the power of 2. And C is going to be the constant coefficient because it is in the constant term. Let me move this just a little bit down so I can put here those names. All right, so leading term and then constant term. Okay, you need to be able to know this. All right, you need to be able to look at a function, a quadratic function, and recognize or know that if the quadratic function it's in standard form or not. Okay, there is another form that is also important, which is the vertex form. We're going to talk about that just in a moment. But whenever you have this type of structure that represents a quadratic function, it is the standard form. You are seeing the standard form. From the standard form, we can get a few things. We can get the coefficients. So we are getting the coefficients, the value of the coefficient, right? Another thing that we can get from the standard form is the vertex location of that quadratic function. Another important aspect or thing that you need to remember, and this is going to be a formula. This is something that you need to remember always whenever working with a quadratic function in our class, is how to identify the vertex. So here, let's talk about location. And location is related to X or Y value. Which of these two variables? The X or the Y value? When we are talking about functions and we refer to the location of the function or the location of the point, do you go by the Y value or do you go by the X value? All right, so I'm seeing here 2 Y's and 1 X. All right, so no, 2 Y's and 1 X. So which one is it? If you need to identify a location in the graph or for a function, do we go by X value or Y value? Think of the past units where the question or the extra is identify the location or where the maximum value occurred, right? You go by the X value. So what we are looking here, the formula that I'm going to give you here is going to give you the location the X value, location of the vertex. This is going to be important. We are going to go back to this formula a lot in our unit, in unit number 4. So you are going to look at the equation of the quadratic function. You need to recognize that the standard form of that equation, right? If you don't have the standard form, then we have other things to do. But Right now, the exercise is going to give us a quadratic function in its standard form, and we need to identify the location of the vertex. So you need to be able to identify who is A, B, and C, the coefficients. Once you got that, then you can go and identify the vertex location by the formula that I am presenting here down. Right? So how do we get the y value of the vertex? So vertex, but now the value. Okay, so the value of the function will be by the y value. So what you want to do is to plug in into the function what you got here. And right now, working with the formula, it is uncomfortable, if you will, because right now you are seeing a form negative b over 2a as an input of the function, right? But this is going to be simplified when we are working with an actual exercise, because instead of plugging in a mathematical expression, we are going to use actual value, right? So that is going to be the y value. So whatever is the value is here when we solve that equation is going to be the y value of the vertex. So the vertex, but now the point is going to be the x value, which is negative b over 2a, and the y value. And all this is when we are working with, you are going to do this when you have the standard form of a quadratic equation, okay? And you need to identify the vertex, its location, and its value, right? So all this information is important. This is something that you need to have in your mind when working with the exercise. So let's see how we apply this to our exercises. So we need to answer this question. And I believe I'm going to just take this. Alright, I do not know how well you see there. So I'm going to, let me zoom in, or maybe copy and paste this, put in this bigger. So if I can put this here. So that is function 1. And then just copy the questions. Okay, still I'm unsure how well you see this on your end. Okay, but basically what we have, and I guess I can write down the equation. That's what I'm going to do. Okay, so before doing that, this is the exercise we have. A quadratic function is being presented by Alex, and we need to answer 3 questions. We need to find the vertex of each of the 2 functions that we have. So the first question is about function number 1, the one that is in the screen, and what we need to do is to identify the vertex of function number 1. All right, so I'm gonna put this on the side because I'm going to now write it down here, and I'm going to use colors. Let me set up this, and then I'm going back to show everything. So blue. Okay, that's better. All right, so we need to, let me also do this. So the question is, what is where? So let's find the vertex, the point, the point of the vertex for this function. All right. So what we want is to identify the vertex. So we want to give the vertex coordinate or the vertex point location just by looking at the equation of this quadratic function. First thing that I want you to notice is that in the standard form, we are seeing ax squared plus bx plus c. Here, we are not seeing plus, we are seeing negative instead of addition. And that detail is important because what is the meaning of that negative? It means if I'm going to translate this into this structure when we use addition operators instead of subtraction operator, what is the meaning of this negative? Well, the meaning of that negative is that the coefficient A is negative, the coefficient B is also negative, and the coefficient C is also negative. So another way to look at this function is by putting another way to look at this function or this equation is by, let's move this just a little bit, putting a plus sign there and then using parentheses to enclose that negative in front of the 12, or just knowing that the negative belongs to the 12, right? So I'm going to use parentheses here to be more explicit and to know that that negative belongs to 12, so B is negative. What I'm doing is completely optional. You don't need to do this. I just want to show you that the sign that it is in front of the 12 and the 15 here belongs to the coefficient B. That negative, that subtraction, it is not just a subtraction. It means that 12, the value of B is negative. Okay? So by looking at this, we can get the value of the coefficients. The value of the coefficient are A is equal -2. B is equal -12, right? And C, okay, come on, is equal to -15. Okay. So that information is important because we are looking for the vertex. So once we got that, the first thing that we want to know is the x value of the vertex of the location. So location, so x minus, so there's going to be a division there, and it's going to be -12, which is the value of B, and all this divided by 2 times -2, which is the value of A, the leading coefficient. And we solve this. Okay, So here we have 4 in the denominator. We have 3 negative signs, so the value is going to be a negative value. And then 12 divided by 4 is going to be 3. So the location of the vertex, Halima, is going to be negative 3. Careful with the y value, because you put there negative 33. Okay? So now let's find the value of the vertex. So the y value. So the y value is going to be, we are going to use the equation, the function rule. Now, instead of using negative b over 2a, we are just going to use this value that we have here. See, that is more straightforward. We don't need to put a formula as an input there. Okay, Rachel, yeah, go ahead.
Okay, so for up here it says b equals negative 12, and then in the equation it says negative b. So would those b's, would the negative of the b and the negative of the 12 not cancel out and make 12 positive?
Okay, so you are talking about this?
Yeah.
All right. So this negative belongs to the formula. Okay, and this negative belongs to the coefficient b.
Okay.
And this negative here goes to belongs to coefficient a. So these two negatives cancel each other, right? And this one is the one that it is extra, and that is why we have a negative there.
Oh, okay, that makes sense.
All right. That's a good question. Careful with the negative. This tiny line in front of a number will have a huge impact on the results. No. All right. So now how to get the y value? So what we are going to get, we're going to use is, let me use this here. The only thing that is going to change is that now x is going to be negative 3 and negative 3. When you solve this, you get a value of, what will be the value here? Tell me on the chat. Okay, I have negative 18. I have negative 18 plus 36 minus 15. This time you can solve, you can put that just as a final number. And I have 3 here, okay? All right, so let's see. So negative 2 here, we follow the order operation, parentheses, exponents, multiplication and division from left to right, addition and subtraction from left to right. All right, here, even we are seeing a set of parentheses, but those parentheses do not have something to solve inside them. So those parentheses are used to be for multiplication or for be explicit about to whom the exponent belongs to, right? So we have parentheses here, but inside the parentheses there's nothing to solve. So we go to the next step, which is going to solving the exponent. So the exponent here brings that negative 3 as a 9 here. 3 times 3 is 9. So we have 2 negatives, they cancel each other. So positive 9. Then again 2 negative, this brings to 36. 12 times 3 is 36. Those negative cancel each other, and then minus 15. Next step, we solve So I did solve the multiplication here because I was working now with the second term. So now negative 18 in the first term, and we got 36, positive 36 minus 15 on all of these is going to be equal to 3. All right. So we have identified the x value and the y value of the vertex for this function. So the point is going to be 3, negative 3, 3. I don't know if I can shrink this. I think it will look good. Let's see. I think so. Yes, no, yes. Okay. So yeah, that is how I use what I have here on the left to do this part here. All right. I have one more question though. This value, so the y value of the vertex, is this 3 a maximum or a minimum? How are we going to know that? What do you think? Tell me on the chat. Is it a maximum or a minimum? Justin, I have here that it is a max. Who else? Max or minimum? Amanda, max because it opens down. Yeah, the parabola opens down. And how do we know that? By looking at the leading term. The leading term has a negative sign, so the leading coefficient is negative. So our quadratic equation, when it has a negative in front of it, or there is a negative, it is a vertical reflection. So that negative leading coefficient means a vertical reflection. Hence, our parabola opens down. The vertex is a maximum. Okay? All right. So you might wonder, what is the written work that you need to present on this type of exercise? Basically, what I did here. This is written work. Okay? Everything else, it shows information for you to know. But for the written work, if you have this type of exercise, I want to see how you use the formula to identify the x value of the vertex, and then how you evaluate the function with that value, right? So this one is a max. So going back to our first question, you will go here, and the vertex is going to be negative 3, 3. When we have the graph, it's very easy. We just need to look at the vertex. So how do I identify the vertex? The one on the peak, or the one that is at the bottom of that parabola. In this case, we have one on the peak, on the top of the parabola. So this is going to be a maximum value. If I'm not wrong here, this is negative 2 here, down below, and 7. So that is the vertex location for function number 2, negative 2 and 7. I should write better, sorry. Negative 2, 7. So those are the vertex for both functions. Which of these two has the large maximum value? Function 1 or function 2? Which of these two function number 2, because of the 7, so function number 2, and the maximum value is 7. Okay? All right. So knowing if a parabola has a maximum or minimum value, it is very important when you are working with optimization later on calculus, or any, if you are going to follow the path of engineering, optimization is something very important. You want to optimize the cost, the production. Hence, we have quadratic function that determines, or we use quadratic functions to determine if we the optimal value, okay, for any specific situation. All right. So standard form. You have seen me how I use the standard form. So if we go back here into the workshop today, item number 15, the first part here says this structure f of x, the way that it is here, it is called the standard form, right? So that's the standard form, and then when the equation is in the standard form, item 17, how do you get the vertex? So now you know it is negative b over 2a. That is going to be the value of the x value of the vertex, and then to get the y value, we just plugging into x the whatever is the value for x, but using that formula, negative b over 2a. Okay. All right, that's another one with standard form. All right. Second exercise that we're going to discuss is related to the vertex form of the quadratic function. All right. So let's start talking about what the vertex form is. All right. So the vertex form now, it is this structure. All right. And what is important here is H, K, and A. You know what? I'm going to use this color for A, and then I'm going to use maybe green. Right. All right, I'm using the same colors, pink, green, and blue. The only one that is related to the standard form is A. A is still the leading coefficient. Okay, H and K, they are using green and blue, but do not confuse them with coefficient B and C. They are related. All right. So now we are going to be talking about again a quadratic function, but the structure of its function of its equation or its function rule, it is in the vertex form, and the vertex form is this way, where we have a open parenthesis x minus h closing parenthesis raised to the power of 2 plus k, and from here we can get the vertex. So the vertex, it is straightforward. H, that is the x value of the vertex, and k, that is the y value. Okay, so x value of the vertex. Okay, so H location, and k is the y value, so the actual value of the function. Okay, so this one we don't need to go and do or use the formula of negative b over 2a, because it is there on the equation. So that's the vertex. So a, we know that a is going to be the leading coefficient. okay? And this is equivalent to the standard form, okay? Every quadratic function can be represented as with its Berter form or its standard form, right? I'm not going to show you how to go through one form to another one here too much. Later in pre-calculus, when you learn about how to complete the square, you will learn how to connect how to go from the Berter form to the standard form, and vice versa. How to go from the standard form to the Berter form, right? So right now we are like working with just the end results, okay? What is happening in the middle between Berter form and standard form. If you want, you can play with the equation, and you will see that you will get to the standard form from the Berter form, and vice versa. From the standard form, you can get to the Berter form. But in our class, it's not going to focus on how to convert Berter form to a standard form and standard form to Berter form. It's going to focus on working off with the Berter form and the standard form, and how to get the properties of that quadratic function. All right. So that is what you need to know about Berter form. And now, how are we going to use the Berter form here? In this exercise, this is what we have. We have the graph of a quadratic function. And our goal is to write the equation that represents that function, right? So how are we going to do that? So I think I'm going to put this here. Oops. Oh, okay. This goes to you. And maybe I can put this down. I think so, yeah. Okay. This is okay. So what you need to know beforehand, before this exercise, is know the structure of the Berter form and know the meaning of h, k, and a. Because now our goal is to write the equation for this function that we have here. And here what we have only is this graph. So the first thing that you are going to do is to identify the vertex. So step 1, vertex. And you are going to take the vertex from the graph itself. So you know that the vertex is -1, -3. From the vertex, what color am I? Green and blue. You are getting the value of h and the value of k. So right now, what we have so far and what we know about our equation is the following. A is still unknown, but now we know the value of h, so the value of h is -1. Question: am I going to put -1 there, or am I going to put +1 there? What do you think? Let me zoom out. Look the Berter form. The value of h is -1. Am I going to put -1 there or +1 there after x? Okay, so I'm going to use -1. Okay. What happened with the negative that it is here? Because in front of h, Tristan, that's what I wanted to see. Yeah. We are going careful with the negative again. Negative, just a tiny mark on your paper that has a huge impact on math. So you go and you need to put the entire h value, right? But you cannot forget about the x minus, right? This negative is not this negative. Careful with that. I'm going to simplify that and you are going to see how it's going to look. And then we have plus, and again, I'm going to just bring down -3 here. I'm going to use parentheses just to separate the addition sign with the negative sign. The simplification, when I simplify this, this is just going to be a times open parenthesis x plus 1. See that 1 now becomes just positive because those two negative cancel each other, and then -3. So maybe minus and then just 3. All right? So now this is the simplification. But keep in mind always the signs. Careful with the signs. So from the first step, we are almost done. The only thing that we need to find is the leading coefficient. So step number 2, leading coefficient. And how are we going to get that? How are we going to know that value? Okay, so we need to find that value. All right. So step number 1 to find this value. So let me put step 2.1. We are going to use a point in the graph, or on the graph, I believe. Point on the graph that is or different from the vertex. Point on the graph different from the vertex. Okay, it is important. So we are going to identify, we are going to take a point on the graph that is different from the vertex. Okay, and using that point is how we are going to get the value for A. Different from the vertex is going to be important. If you use the vertex, what you are going to do at the end in the equation that we are going to use, you are going to cancel everything, and then you are going to end with 0 equals 0, and then you are not going to get a value for A. All right, so you are going to select a point different from the vertex. My recommendation, if possible, is use the y-intercept. What is the y-intercept? The y-intercept is when x is equal 0, and then you are going to have a value of x there. Okay, this is not going to be always possible, but if you can use it, if you can identify the y-intercept where x value is going to be 0, and then you are going just to take whatever the y value is, it's going to make things easier for you. All right, so that's the number 1. So let's go to our graph and see what are the values that we have here. So right now the x-intercept, the y-intercept is around here, right? So what I know about the y-intercept is the x value is equal 0, but there is a problem. I do not know exactly what the y value is here, right? So right now it is not a good idea to use the y-intercept, okay, because it's not explicit the exact y value here. So the other point that we have is this one here, -2, -1. So we are going to select that one. Okay. So the point that we are going to select is -2, -1. From this point, we can get the following. The x value is -2. And we know that the -1 is the y value. In other words, if we plug in -2 into the equation, its value needs to be -1 because this is the y value. Does that make sense? Any question on this part here? Because this is a critical step to finish this exercise. Any question here? Right? So from the second point that we have selected, we get the x value and the value for the function. The x value, remember, is the input or the location. The y value is going to be the actual function value. So how do we use this information? So now, step 2.2, this is what we had so far. This is what we have so far. So now we are going to solve for A, for the coefficient, for the leading coefficient. So for A. And we are going to use the information that we got from the second point. So we know that when x is equal -2, the value of the function is equal -1. So that means that f of -2 equals -1. Let me put this in a better representation. F on the left side, I have f of -2, right? On the right side, I'm going to use this. But what I'm going to do is to substitute x with -2. All right? And let me put this in another color so you can identify it. So which one is a good color? Maybe orange? Yeah. All right, so that -2 comes from this point. Or that point we got -2. So what we know about f of -2? Well, that its value is equal to -1. So -1 equals A times open parenthesis -2 plus 1 to the power 1 minus 3. And what happened here? Well, we have only one unknown variable here and one equation. So now we can solve for the value of A. All right. So now we solve for the value of A. Right. So what does that mean? We need to isolate A in one side of the equation, and then the other side is going to contain its actual value. Okay, so this is a good moment for taking a break. So I'm gonna leave it there. I'm going to take a break, but I'm going to give you 5 to 10 minutes. Try to solve this equation for A. Tell me the value that you got on the chat, okay? And I will get back here in 10 minutes, okay? Any question before I go? All right, so when you have your question ready, please post that on the chat. We are going to review your question and then we are going to finish this exercise, okay? I will get back here in 10 minutes.